Yo, 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 yo. What's up, droids? We're going to continue the stream where we left off last. If anyone doesn't remember, we are working in the Godot game engine docs. So we're going to do your first 2D game tutorial right now. We're just going to walk through the docs. Nothing exciting yet, but we're just putting in the learning so we can hit the ground running. Okay, actually it's opposite of hitting the ground running, right? Because we're taking our time, but we're building up the tools necessary to build the 2D game that we're trying to build. Okay, the 2D game that we're trying to. All right, let's get started. So briefly, here's what you're going to learn. Create a complete 2D game with Godot editor, structure a simple game project, move the player character and change its sprite, spawn random enemies, count the score, and more. You'll find another series about 3D. I'm more focused on 2D, obviously. So why start with 2D? If you're new to game development or unfamiliar with Godot, we recommend starting with 2D. This will allow you to become comfortable with both before tackling 3D games. And there's a completed game, prereqs, step-by-step tutorials intended for beginners who followed the complete getting started. Yay, we did that. Check out the first stream from 2 days ago. All right, if you're an experienced programmer, you can find the complete demo source code here, down to the Grape source code. We prepared some game assets you'll need to download so we can jump straight into the code. You can download them by clicking on the link. Go ahead and do that. And let's set up the project. In the short first part, we'll set up and organize the project, launch Godot, and create a new project. When creating the new project, you only need to choose a valid project path. You can leave the other default settings alone. All right, let me unzip these just so we have them. All right, download the assets, did that. The archive contains the images and sounds you'll need you'll be using to make the game. Extract the archive and move the art / fonts directories to your projects directory. Your project folder should look like this. Art and fonts. Okay, let's do it. Godot. Godot. G'day. New project. Let's say starter 2D. Cool. What is this render? Forward Plus supports desktop platforms only. Advanced 3D graphics available. Can scale to large complex scenes. Uses rendering device backend. Slower rendering for simple scenes. This would be mobile. Supports desktop plus mobile platforms. Less advanced 3D graphics. Less scalable for complex scenes. A rendering device backend. Fast rendering for simple scenes. Compatible. Supports desktop mobile. So that adds desktop. Oh, that desktop. Oh, web. Adds web. Intended for low-end older devices. I guess we'll just do this first. You cannot save a project in the selected path. Please make a new folder or choose a new path. Create folder. Boom. Create and edit. Let's do it. Open up on my other screen. Waiting for it to load. And it crashed. No joke. Relaunching. Relaunching. Opening. Loading. And looks like it's going to load this time. All right. So let's see. Do we have a project folder? Yes, here. So let's see if I can drag and drop them downloaded assets. So there's font and art. I'm going to drag both, see what happens. Looks like it worked. Go into art. Beautiful. On art icon. Yep. This game is designed for portrait mode, so we need to adjust the size of the game window. Click on project settings to open the project settings window. In the left column, open the display window tab there. Set viewport width to 480, so 480 by 720. 480 by 720 in the viewport settings, which is editor settings, viewport, view, see if the search works. Editors 2D? No. All right, let's read the doc. It said project settings. Project settings. That makes more sense. Search for view. Viewports. Transparent background. HDR 2D. Advanced settings. Don't see the option. Oh, there we go. Localization. No. Project settings window in the left. Display window. Where did I get viewport from? There it is. All right. 480. 480. 720. That's not 720. Cool. Also under the stretch option, set mode to canvas items and aspect to keep. This ensures that the game scales consistently on different size screens. What is canvas items? Organizing the project. In this project, we will make 3 independent scenes: player, mob, and HUD, which we will combine into the game's main scene. In a larger project, it might be useful to create folders to hold the various scenes and their scripts. But for this relatively small game, you can save your scenes and scripts in the project's root folder identified by res:// You can see your project folders in the file system dock in the lower left corner. With the project in place, we're ready to design the player scene in the next lesson. Okay, let's do it. Creating the player scene with the project settings in place, you can start working the player-controlled character. The first scene will define the player object. One of the benefits of creating a separate player scene is that we can test it separately, even before we've created other parts of the game. To begin, we need to choose a root node for the player object. As a general rule, a scene's root node should reflect the object's desired functionality, what the object is. Click the Other Node button and add an Area 2D node to the scene. Godot will display a warning icon next to the node in the scene tree. You can ignore it for now. We will address it later. With Area 2D, we can detect objects that overlap or run into the player. Change the node's name to player. By double-clicking on it, now that we've set the scene's root node, we can add additional nodes to give it more functionality. Before we add any children to the player node, we want to make sure we don't accidentally move or resize them by clicking on them. Select the node and click the icon to the right of the lock. Its tooltip says, make selected nodes children not selectable. Save the scene, click save. For this project, we'll be following the Godot naming conventions. GD script classes nodes use Pascal case, variables and functions use snake case, and constants use all caps. All right, let's see how much of that I read to. That saves. Okay. 2D. Other node, area 2D. Give it a name of player. Save scene. Lock this thing. Is it locked? Ungroup selected node, shift command, make selected node children selectable. Nope. File. Save scene. Player. Save. Okay, done. Spray animation. Click on the player node and add child node, animated sprite 2D. The animated sprite 2D will handle the appearance of animations for our player. Notice that there is a warning symbol next to the node, and animated sprite 2D requires a sprite frames resource, which is a list of animations it can display. To create one, find the sprite frames property under the animation tab, and in the inspector, click empty new sprite frames. Click again to open the sprite frames panel. Animated sprite 2D, sprite frames, animated sprite 2D, and then it gave us a warning. A sprite frames resource must be created or set in the frames property. Frames property should be in the inspector. Let's look for frames. Where in the world are frames? Frames, node script. Don't see frames. Where are the frames? Animation, right? Okay. Sprite frames. Quick load. New sprite frames. Empty new sprite frames. Got it. Click again to open the sprite frames panel. Oh, missed that bit. Got it. On the left is a list of animations. Click the default one and rename it to walk. Then click the add animation button to create a second animation named up. Find the player images in the file system tab. They're in the art folder you unzipped earlier. Drag the two images for each animation named player gray up 1, 2 and player gray walk 1, 2 into the animation frame side of the panel for the corresponding animations. So up and walk add their animations. So this guy becomes walk, and we make a new one called up. Then we go into art. We look for that little monkey guy. Player gray up 1 and 2. Going up. Oh, not gonna let me do that. Okay, walk. Put them over here. Click on up. Up. Very intuitive. Great. The player images are a bit too large for the game window, so we need to scale them down. Click on the animated sprite 2D node and set the scale property to 0.5.5. You can find it in the inspector under the node 2D heading. Okay, it should be easy enough. Was it the player or the animated sprite? I think it was the animated sprite. Scale under transform. Scale 0.5.5. Okay. Just to double check, that was under transform scale node 2D. You find this the player. Click on the animated sprite 2D. Yep. Finally, add collision shape 2D as a child of player. This will determine the player's hitbox or the bounds of its collision area. For this character, a capsule shape 2D node gives the best fit. So next to shape in the inspector, click empty new capsule shape 2D. Using the two size handles, resize the shape to cover the sprite. Okay, capsule shape 2D. Collision shape 2D. Let's do it. Collision shape 2D. And then under here, we choose capsule, new capsule shape 2D. And then we zoom in. Use our other mouse here. Oops. There we go. And I gotta resize this little capsule. Maybe that way. Maybe that. How about that? What do you guys think? Here or here? A little bigger or a little smaller? A little bigger? A little smaller. Let's go a little bigger. Oh, you did a little smaller. A little smaller. When you're finished, your player scene should look like this. Make sure to save the scene again after the changes in the next part. We'll add a script to the player node to move and animate it. Let's do that. And we'll go ahead and save too, because you better do that. Okay. All right, coding the player. In this lesson, we'll add a player movement animation and set it up to detect collisions. To do so, we need to add some functionality that we can't get from a built-in node. So we'll add a script. Click the player node and click attach script. In the script settings window, you can leave the default settings alone. Just click create. If you're creating a C# script or other language, selecting the language from the language drop-down menu before hitting create. All right, as we did in the first stream, we're going to use GDScript, which is kind of like a Python language. Area 2D, inherits. Okay, so they're doing this on the player. They're adding a new script. They're not giving it a name. It's just .gd. All right, well, we can do that. Script. I think I did that wrong. Right-click, add script. Attach script. How do they make a new script? Player node and click attach script. Okay, so it is attach script. Defaults. Cool. If this is your first time encountering GDScript, please read scripting language before continuing. Start by declaring the member variables this object will need. Export var speed 400, how fast the player will move, var size. Yeah, well, it's fine. Let's do it. Annotation, export, var size was 1. What was the other one? Var size, something 400. Var speed equals 400. Our size is actually screen size. Okay. Using the export keyword on the first variable speed allows us to set its value in the inspector. This can be handy for values that you want to be able to adjust, just like a node's built-in properties. Click on the player node and we'll see the property now appears in the script variables section of the inspector. Remember, if you change the value here, it will override the value written in the script. If you're using C#, you need to rebuild the project assemblies whenever you want to see a new export variables on signals. This build can be manually triggered. Your player GDScript should already contain a ready and a process function. If you didn't select the default templates shown above, create these functions while following this lesson. The ready function is called when the node enters the scene tree, which is good time to find the size of the game window. So we're going to say screen size equals get viewport rect.size. Yeah, get rect. Get rect, guys. Get wrecked. Sorry, it's not funny. Except it is. Get rickety wrecked. Get screen transform dot wrecked. No, that was not it. It was like underscore get screen. Dang it. Why do I always think it's underscore? Because the functions are underscore. Get viewport rect. Get viewport rect dot size. Save. Right, now we can use the process function to define what the player will do. Process is called every frame, so we'll use it to update elements of our game, which we expect will change often. For the player, we need to do the following. Check for input. Move in the given direction. Play the appropriate animation. First, we need to check for input. Is the player pressing a key? For this game, we have 4 direction inputs to check. Input actions are defined in the project settings under input map. Here you can define custom events and assign different keys, mouse events, or other inputs to them. For this game, we will map the arrow keys to the 4 directions. Click on project settings to open the project settings window and click on the input map tab at the top. Type move right to the top bar and click add button to add move right. Project settings input. Oh, it's this tab. All right, add a new action. Add new action. Move right. There we go. We need to assign a key to this action. Click plus icon on the right to open the event manager window. The listening for input field should automatically be selected. Press the right key on your keyboard and the menu should look like this now. Right. Select OK button. The right key is now associated with right movement action. Move these steps, repeat these steps to add 3 more mappings. Move left, up, and down. Okay. My keyboard's a little weird, but that's my move right. Add another one. Move left. Left. Move up. Move. And one more. Move down. Down. No. Down. Okay. Physical, 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 physical. Right, left, up, down. Okay. Click the close button to close the project settings. We only mapped 1 key for each input action, but you can map multiple keys, joystick buttons, or mouse buttons to the same input action. Very cool. You can detect whether a key is pressed using input is action pressed, which returns true if it's pressed or false if it isn't. Process velocity, vector 2 starts at 0. If input action pressed, move right, velocity x +1, left -1. Down is +1 to the y, -1 to the y for up. So right 0, or right plus, left negative, down plus, which is weird. Oh, because it's going down. Okay. Yep. Okay. Velocity length greater than 0. Velocity equals the velocity normalized times the speed. Okay, animated sprite 2D play. That's going to tell it to play its sprite, else stop its sprite, because you have no velocity. You're not moving, right? Why would you animate? Makes sense, right? I think so. Alrighty then, let's do that. Process velocity equals vector 0. Var velocity equals vector 2.0. Great. And then there's like this big old if action input. Where do you check input? The screen? No. Game? No. Is it just is action? Is it input? Input dot is action. There it is. Is action pressed? And then move. We're going to do left first. Okay. And then if it is, you fall into this little if. I'm going to make this bigger, guys. Okay. If it is, then you say direction, velocity equals vector 2D. No, was it vector 2D? I think it's just equals -1, right? If input dot is action pressed, we'll go with right. Then velocity equals 1. All right, let's see. Plus equals, and it's velocity x. I knew I was forgetting something. Oops. Okay. All right. Yep. One is minus, but you could just say plus -1. And okay, left was second. That's why it's minus. Okay. We'll do this. We'll say minus, and we'll get rid of this. If you want, we'll even move this down. Didn't work. Shortcuts are different. Shortcuts are different in this editor. Cool, then I'm going to duplicate both of these. Nope, doesn't want me to duplicate. Sad. Okay, if it is... What? Up next, down. And this one is positive. Move down. Plus 1 to the Y. Up. Minus 1 to the Y. Save that. All right. We have to do this if velocity length is greater than 1. Velocity equals velocity normalized times speed. Interesting that velocity has a length. It's greater than 0? I thought it was greater than 1, but why greater than 1? Okay, it's 0. Okay, it makes more sense. Then we set the animation. So it's like animated sprite 2D dot play. Was it play? Do you guys remember? Who was watching? Who remembers? Dot start. I don't remember what it was. It is play, but I missed a step. Velocity equals normalized times speed. Do we have a speed? Where do we get speed? Oh yeah, that's our set on our property. Velocity equals cool. And this is it is dot play. Just don't know why that doesn't show up. Okay. Else stop. Cool. Restart by setting the velocity to 0, 0. By default, the player should not be moving. Then we check each input and add or subtract from the velocity to obtain a total direction. For example, if you hold right and down at the same time, the resulting velocity vector will be 1, 1. In this case, since we're adding a horizontal and a vertical movement, the player would move faster diagonally than if it just moved horizontally. We can prevent it that if we normalize the velocity, which means we set its length to 1, then multiply by the desired speed. This means no more fast diagonal movement. Yeah, I was watching a video about this. It makes sense. You said it's length 1 though. If you never use vector math before or need a refresher, definitely need a refresher. You can see an explanation of vector usage in Godot at vector math. It's good to know, but won't be necessary for the rest of the show. Yeah, definitely need a refresher. All right, it's been so long. Let's see, coordinate system. 2D space coordinates are defined using horizontal axis. Yep, 0, 0 is top left. Right. Particular position in 2D space is written as a pair of values. 4, 3 is here. Note, if you're new to computer graphics, it might seem odd that y-axis points downwards, upwards, as you probably learned in math class. However, it's common in most computer graphics applications. True. Any position 2D plane can be identified by a pair of numbers. In this way, however, you can also think of the position 4, 3 as an offset from 0, 0 point or origin. Draw an arrow point from the origin to the points. This is a vector. A vector represents a lot of useful information as well as telling us that this point is 4, 3. We can also think of it as an angle, 0 theta, and a length of magnitude m. In this case, the arrow is a position vector. It denotes a position in space relative to the origin. A very important point to consider about vectors is that they only represent relative direction and magnitude. There's no concept of vector position. The following two vectors are identical. Okay, right. So that's how the movement works, is it takes where you're currently at and it moves 1, 1, or 1, 1, 1, 1, whatever, right? And then we got to find out about normalized. We'll get there. Both vectors represent a point 4 units to the right and 3 units below some starting point. It does not matter where on the plane you draw the vector. It always represents the relative direction and magnitude. Vector operations, you can use either method x and y coordinates or angle and magnitude to refer to a vector, but for convenience, programmers typically use the coordinate notation. For example, in Godot, the origin is the top left corner of the screen. So to place a 2D node named node 2D 400 pixels to the right and 300 pixels down, you would use the following code: vector 2, 400, 300. Godot supports both vector 2 and vector 3 for 2D and 3D usage, respectively. The same mathematical rules discussed in this article apply to both types, and wherever we link to vector 2 methods in the class reference, you can also check out the vector 3 counterparts. The individual components. The individual components of the vector can be accessed directly by name. So you get the x, you can get the y. When adding or subtracting two vectors, the corresponding components are added. A plus b, so 2, 5 plus 3, 1 equals 5, 6. So this guy plus this guy equals this guy. So 2, 5 plus 3, 1 is 5, 6. 3, 1 plus 2, 5 is 5, 6. Note that adding a plus b gives the same result as b plus a, scalar multiplication. Vectors represent both direction and magnitude. A value representing only magnitude is called a scalar. Scalar use the float type in Godot. A vector can be multiplied by a scalar. So you can times it by 2, divide by 3, times by minus 2. So in this case, 2, 3 times 2 is 4, 6. Multiplying a vector by a positive scalar does not change its direction, only its magnitude. Multiplying with a negative scalar results in a vector of the opposite direction. This is how you scale a vector. Let's look at two common uses for vector addition and subtraction. Movement. A vector can represent any quantity with a magnitude and direction. Typical examples are position, velocity, acceleration, and force. In this image, the spaceship at step 1 has a position vector of 1, 3 and a velocity of 2, 1. So he's going to go over here. The velocity vector represents how far the ship moves each step. We can find the position for step 2 by adding the velocity of the current position. Position 2 equals position 1 plus its velocity. Velocity measures the change of position per unit of time. The new position is found by adding the velocity multiplied by the elapsed time, here assumed to be 1 unit, e.g. 1 second, to the previous position. In a typical 2D game scenario, we would have a velocity in pixels per second and multiply it by the delta parameter, time elapsed since the previous frame, from the process or physics process callbacks. Pointing toward a target. In this scenario, you have a tank that wishes to point its turret at a robot. Subtracting the tank's position from the robot's position gives the vector pointing from the tank to the robot. Okay, so you have the tank. Subtracting the tank's position from the robot's. So take, what is this? 1, 2, 3, 4. 1, 2, 4, 2, and subtract 3, 2, 3, 4, 5, 3, 5. To find a vector pointing from A to B, use B minus A. Unit vectors. A vector with magnitude of 1 is called a unit vector. They are also sometimes referred to as direction vectors or normals. Unit vectors are helpful when you need to keep track of direction. Normalizing. Got to normalizing. Normalizing a vector means reducing its length to 1 while preserving its direction. This is done by dividing each of its components by its magnitude. Because this is such a common operation, Godot provides a dedicated normalized method for this. A.normalize. Because normalization involves dividing by vector's length, you cannot normalize a vector of length 0. Attempting to do so would normally result in error. In GD script, though, trying to call the normalize method on a vector of length 0 leaves the value untouched and avoids the error for you. So I really want to know what the output of this is. It's just not, like, I need to see it in my head. Okay, so x, let's see, if you pressed right, velocity x becomes 1. If you're also holding down, y becomes 1, so it's 1, 1. So that's a diagonal movement of 1, 1, right? Velocity length is greater than 0. So if it was 0, 0, then it would be length 0. But if it's 1, 0 or 1, 1 or 0, 1, then it's greater than 0. Then you normalize the velocity. So you take a 1, 1 and you times it by its magnitude. So what's the magnitude? It's 1 times 1. Isn't that still 1, 1? 7 example. What's divided? Equivalent. Okay. Returns the result of scaling the vector to unit length, equivalent to v divided by v dot length. This function may return incorrect values if the input vector length is near 0. Returns true if the vector is normalized and its length is appropriate. Approximately equal to 1. Okay. So this is not setting direction. This part is just getting speed. So these are directions: move right, move left, move down, move up. But they're trying to decide how many frames to move it. So they're going to multiply the direction times the speed. Makes sense. But when you're moving diagonal, you have both a move right 1 and a move down 1. So that would normally be twice as much movement. But they divide by 1, divide by the length, which is 2. What does the length come out to on a vector? Is a vector? Velocity. Go back. Oops, how do you go back? Velocity. What's the length on a velocity? Returns the length magnitude of this vector. Okay, so we just talked about magnitude. Magnitude. Okay, so magnitude. So we went 1, 1. Then the magnitude is the length, which is 1. Isn't it the same as going 1, 0? Isn't the magnitude still 1? The magnitude's the same for a diagonal or a down. Okay. So are you always divided by 1 in this case? Turn it to the length. Okay, so we get the length, and then we normalize it, which takes the velocity 1, 1 and divides by 1. How do you divide 1, 1 by 1? I'm so confused. Did he add them? Did it say two? Did it say somewhere that the vector's 2 numbers? How does this make sense? Adding vectors to when adding or subtracting 2 vectors, the corresponding ones are. So if you want to point, you subtract. All right. Normalizing a vector means reducing its length to 1 while preserving its direction. But that was already 1. This is done by dividing each of its components by its magnitude because it is such a common operation. Godot provides a dedicated normalized method for this. I guess I don't understand the length. If the magnitude is 1 for a diagonal movement, backwards movement doesn't matter. Whatever. All right, a common use of unit vectors is to indicate normals. Normal vectors are unit vectors aligned perpendicularly to a surface defining its direction. They're commonly used for lighting, collisions, and other operations involving surfaces. For example, imagine we have a moving ball that we want to bounce off a wall or other object. So this would be the normal, this would be the direction it's moving, this is where it's going to reflect. The surface normal has a value of 0 minus 1 because this is a horizontal surface. When the ball collides, we take its remaining motion, the amount left over when it hits the surface, and reflect it using the normal in Godot. There's a bounce method to handle this, where here is a code example of the above diagram using a character body 2D. Collision, kinematic collision, move and collide, velocity times delta. If collision, reflect. Collision.get remainder, so this red line, call bounce. Collision.get normal to get this normal. Calling bounce on a remainder, passing a normal, it's going to return this reflect vector. The velocity should equal the velocity dot bounce collision get normal. So that's the so just trying to get the direction from where it hit. If this dot bounce takes the collision normal as well, move and collide, reflect. It's interesting. So the velocity is calculated off the current velocity. I guess you have to know how fast it's going here to know how fast it needs to move away from there. Okay, got it. The dot product is one of the most important concepts in vector math, but it is often misunderstood. Dot product is an operation on two vectors that returns a scalar. Unlike a vector, which contains both magnitude and direction, a scalar value has only magnitude. The formula for dot product takes two common forms. A times B equals magnitude of A, magnitude of B, cosine theta, what is that one? And A times B equals A x bx plus ay by. The mathematical notation A represents the magnitude of vector A and ax represents the component of vector A. The x component of vector A. However, in most cases, it is easiest to use the built-in dot method. Note that the order of the two vectors does not matter. So A dot B or B dot A is the same thing. The dot product is most useful when used with unit vectors, making the first formula reduce to just cosine 0, cosine theta, cosine whatever that is. This means we can use the dot product to tell us something about the angle between two vectors. So A dot B is greater than 0. This case, A dot B is less than 0. A dot B equals 0. When using unit vectors, the result will always be between -1, 180, and 1, 0. So if this is 0, -1 is 180, from here. 1 is 180 from here. 0, 1. Got it. Facing. We can use this fact to detect whether an object is facing forward toward another object. In the diagram below, the player P is trying to avoid zombies A and B. Assuming a zombie's field of view is 180, can they see the player? That depends on its range. It is facing the player, but I don't know about the range. The green arrows FA and FB are unit vectors representing the zombie's facing direction, and the blue semicircle represents the field of view. For zombie A, we find the direction vector AP pointing to the player. Use P minus A and normalize it. However, Godot has a helper method to do this, calling direction 2. If the angle between this vector and the facing vector is less than 90, then the zombie can see the player. So you do if, so direction to P, A to P, okay, gives you AP. If AP dot FA, just the direction they're facing, if the difference between these is greater than 0, which we know to be 90 degrees, print AC is P. Cross product. Like the dot product, the cross product is an operation on two vectors. However, the result of the cross product is a vector with a direction that is perpendicular to both. Its magnitude depends on their relative angle. If two vectors are parallel, the result of their cross product will be a null vector. Cross product is calculated like this. Cx equals ay times bz minus ac times by. With Godot, you can use the built-in vector 3 cross. Interesting. Cross product is not mathematically defined in 2D. The vector 2.cross method is a commonly used analog of the 3D cross product for 2D vectors. In the cross product, order matters. A.cross B does not give the same results as B.cross A. The resulting vectors point in opposite directions. Calculating normals. One common use of cross products is to find the surface normal of a plane or a surface in 3D space. If we have the triangle ABC, we can use vector subtraction to find two angles, AB and AC. Using the cross product, AB times AC produces a vector perpendicular to both the surface normal. Here's a function to calculate a triangle's normal. Get triangle normal, ABC, find the surface normal given three vertices. Side 1 equals B minus A, side 2 equals C minus A. Normal, side 1 dot cross side 2 is the normal. Okay. Pointing to a target in the dot product section above, we saw how it could be used to find the angle between two vectors. However, in 3D, this is not enough information. We also need to know what axis to rotate around. We can find that by calculating the cross product of the current facing direction and the target direction. The resulting perpendicular vector is the axis of rotation. Dang, okay. Well, that was a nice little math lesson. Definitely more to refresh on. All right, let's move on with this game. Here we go. We start by setting the velocity to 0, 0. By default, the player should not be moving. Then we check each input and add subtract from the velocity to obtain a total direction. For example, if we hold right and down at the same time, the resulting velocity vector is 1, 1. In this case, since we're adding horizontal and a vertical movement, the player would move faster diagonally than if it just moved horizontally. We can prevent that if we normalize the velocity, which means we set the length to 1, then multiply it by the desired speed. This means no more diagonal movement. We also check whether the player is moving, so we can call play or stop. $sign is shorthand for get node. So in the code above, animated sprite 2d.play is the same as get node animated sprite 2d.play. In GDScript, returns the node at the relative path from the current node, or returns null if the node is not found. Since animated sprite 2d is a child of the current node, we can use animated sprite 2d. Now that we have a movement direction, we can update the player's position. We can also use clamp to prevent it from leaving the screen. Clamping a value means restricting it to a given range. Add the following to the bottom of process function. Make sure it's not indented under the else. All right, so we got their direction. Now we actually need to move them. We know what velocity is. We know how much time has passed since the previous frame. So you do velocity times delta. The position dot clamp vector 0 screen size is to keep them in on the screen. Cool. All right, put this guy out of here. There. But here. Cool. The delta parameter is the process function refers to the frame length, the amount of time that the previous frame took to complete. Using this value ensures that your movement will remain consistent even if the frame rate changes. Click play scene on Mac and confirm you can play the player around. You can move the player around the screen in all directions. If you get an error in the debugger panel that says attempt to call function play in base null instance on a null instance, this likely means you spelled the name for animated sprite 2D node wrong. Node names are case sensitive. Let's see what error we get. Save. Play scene. Right, so we're going to go right. Down. I can't hold it down. I must have used the wrong. Is pressed. I used just press. I knew we were going to have a bug. I knew it. I had a feeling. Guys, and we did. We had a bug. That's why we test. Okay. How about now? Right? Ooh, down. Ooh. And you can't go off screen. Cool. Very cool. And just to see what it'd be like if we didn't normalize. It should be faster diagonal. So that's diagonal versus left, right. Diagonal, way faster. Which technology? This is an open source, free to use, free to build, free to edit, free to anything game engine called Godot. It's pretty cool. Very simple. Alright, so that's why we need normalize. But to better understand this freaking math, I'm going to see if I can console log. I don't know if they have that. Oh, they have, it's called print. So let's do print. We're going to print velocity dot. Let's put velocity first. And let's print. Oh, can't duplicate the line, sadly. Now we'll do velocity normalize. Yeah, that guy. All right, let's try this. You can see the difference. So I need to press just one direction, right? So it's always 1, 0, even after you normalize. Down is going to be 0, 1. If I press both together, it should be 1, 1. And then normalize comes out to 0.7 and 0.7. So that you don't move 2 spaces instead of 1 total. How is that possible? Yeah, I don't understand how divide by 1 works here. don't quite understand what's happening. Like, how do you get 0.7? So how's 70% side and 7%? So this comes out to 140%, right? Aren't you moving faster at that point? Yeah, whatever. I'm too tired for math right now. Okay, let's move on. Now that the player can move, we need to change which animation the animated sprite 2D is playing based on its direction. All right, we have the walk animation, which shows the player walking to the right. The animation should be flipped horizontally using flip H property or for left movement. We also have the up animation, which should be flipped vertically with flip V for downward movement. Let's place this code at the end of the process. Okay, so if velocity X is not equal to 0, we want to do some flipping. So if X is not, so if you're moving in a direction left or right, you want, see the note below about Boolean assignment, flip horizontal, velocity X less than 1. Okay, so this will say, if it's less than 1, flip it. Otherwise, don't flip it. And then you don't want to flip V at all because you're only moving sideways. Interesting. So if you're moving diagonally, then you only end up doing the horizontal flip potentially. Okay. All right. Animation. So animation equals walk and flip V. All right. Like if player dot x. No, what was it? Velocity dot x value of RMS root mean square is 70 of the peak value, or the peak value is 1.414 times RMS effective value. Thank you. I still don't get it, but thank you. Root mean square. Yeah. It's awesome that you know that. And I used to do that at some point. Okay. Velocity X not equal 0 is what we're going for. Velocity X not equal to 0. I said not equal to 0. All right, if that's the case, then we need to do something with the animation. What do we want to do with the animation? Animated sprite 2D. Alternating between X and Y. Let's look it up. Y root mean square. Like, what the heck are you asking me?
Root mean square RMS is
Gotta add the voice on. So bad. What's up, Uka? This is so bad. It's good news. Let's change the flow.
Here are some key reasons why RMS is important and what
that's really bad.
Quantifying variability.
None of these are good.
Provides a measure of the magnitude of a varying quantity.
It's particularly
Should I wobble?
in contexts where variations can have both positive and negative values.
It's so bad.
Some alternating electrical current.
That's really bad. All right. Root mean square statistical measure used in various fields, including mathematics. The reason why RMS is important, whether it's quantifying variability consistent. When normalizing vectors for video game characters diagonal movement.
Normalizing vectors is crucial in video game development, especially when dealing with character movements, such as diagonal movement. Here's why and how it is used in this context. Equal movement speed in all directions. In video games, characters typically move at a constant speed regardless of direction. Without normalization, moving diagonally, combining two-directional movements, like left and up, would result in a faster movement than moving in a straight line, just left or just up. This is because the diagonal vector is longer than the straight line vector.
It's longer.
Normalizing the diagonal vector ensures the character moves at the same speed in all directions.
That answers it. Diagonal's longer. How is the diagonal longer, though? Square, is it really? Because you're going across the whole square. If my brain broke, why is it longer? Why is the diagonal longer? Isn't it still one?
The diagonal being longer in the context of a square or rectangle is best understood through the Pythagorean theorem, a fundamental principle in geometry. Let's break it down. Pythagorean
It's a right angle.
This theorem states that in a right-angled triangle, the square of the length of the hypotenuse, the side opposite the right angle, is equal to the sum of the squares of the lengths of the other two sides. Mathematically, this is expressed as a 2 plus b2 equals c2a squared plus b squared equals c squared a2 plus b2 equals
my favorite subject.
A and b
It is longer. Why? It's weird when you.
C is the length of the hypotenuse.
That totally explains it. Okay, you need to move. It's not 5. Yeah, exactly. A squared plus b squared equals c squared. Thank you. It's coming back. All right. So if you moved so if you're trying to move 1, 1, right, that would give you a velocity of like 2, we'll say. You don't want to move 2, you want to move 1, but you can't move just half of 1 and left and half down because you're moving diagonal. It's longer. And so that's why the diagonal ends up being 0.7, whatever it was, in 0.707 in the horizontal and the vertical, so that you can get across that hypotenuse. Okay, it makes sense, guys. It clicked. Triangles. I hate triangles. So I'm not a carpenter. All right, what were we doing here? Who remembers? Anyone remember? Animate sprite, we're like gonna flip it if something. Velocity.x is not equal to 0, then it's moving in a horizontal direction. So if it's moving in a horizontal direction, you want to you want to change it to walk instead of up. So how do I set the sprite? Set sprite? Is that what it was? Sprite equals? I don't remember. So sprite equals. We're going to look it up. I remember, I'm trying to do this from memory so I can actually remember this stuff. It was animation, not sprite. Okay. Animation equals walk. Alrighty. And then we want to set animation something false. We want to set animation up false. That doesn't make sense. Already moving the position. Flip. Vertical flip to false. You just got here. Okay. So what we're talking about now is if your character is moving. Let's see if I can play or if this is going to be broken. All right. So this is what we got. If you haven't seen this guy only animates in his walking animation, but we actually have another animation for when he's going up, and you see his eyeballs kind of looking right. So even when I walk left, his eyeball's still right. So we want to flip him depending on if he's walking up, down, right, or left. So there's a horizontal and a vertical flip we can do. When we're walking right or left, we don't care about flipping the up and down vertical, right? We don't care about that. We're just going to keep it horizontal no matter what. All right. So with that said, we want to turn the vertical. We want to make sure we're not doing any vertical flipping. So How do you handle the vertical flip? I don't remember. It's probably under animated dot v flip vertical. No, it's a v, something v, flip v. Probably not on the sprite. We're gonna go back to the doc. Figure this out, guys. It is on the sprite. It is called flip. It's flip v. I wasn't too far off. Okay. Flip. It just doesn't autocomplete. The autocomplete sucks, apparently. False. All right. And then we want to calculate if we should flip horizontally. So remember, it's going to the right by default. So we only need to flip if you're going to the left. And you're going to the left if your x is negative. So we say animated sprite 2D dot flip h equals, and then we just do the Boolean math here. So velocity dot x is less than 0. I think that's right. And then if, oh, you know what? I lied before. I think it is an if, not an if else. No, it isn't an if else. Okay. If. Python syntax. Yeah, delta x has to be negative, I think. Less than 0, x less than 0. Yep. All right, velocity y not equal to 0, up. Okay, if velocity dot y is not equal. Cool. Animated dot animation. Autocomplete's completely dead. All right, now we're going up. Even if you're going down. Is that right? Oh yeah, because you're going to flip it if you're going down. All right, and then we don't need to set flip horizontal to false, apparently, because this is an else if. Got it. All right, the only thing we have to do is the flip for down. So flip v equals velocity dot y less than 0 or greater than, because I know this one's weird because you're going to be positive for going down. So I actually think this one is greater than. We'll check though. It is greater than. Cool. Let's see if that worked. See if our little guy flips. Come on, dude. Do a flip. All right. It looks so bad. Is that what it's supposed to look like? I can't believe that's what it's supposed to look like. Maybe is he swimming? Oh, maybe he's like in space. And then going right. Going left. The little eyeball. Don't have sound effects, so I'm just going to add my own. Diagonal. Yeah, so if you're going diagonal, it just does the horizontal. It doesn't like flip up. So what if I'm flipping up or down and then I go horizontal? Yeah, it just does this first one. I'm curious what would have happened if we didn't do this. Like if we would have just did both. You think it's going to flip back and forth or something weird? I bet it will. Let's see. Nope, but it is going down while you're walking diagonal. Okay, so they must not want you to do this. That looks weird, I guess. If you're going down, you should never, or if you're going diagonal, you should never flip down. That's what they're trying to say. Okay, let's see. Right, down. Yeah, I guess that looks better. Start out there, then you do that. You just like immediately flip upwards, I guess. Oh yeah, man, it looks neat. If it's a Pokemon style game, you would never need that vertical flip. So the game I'm actually trying to make has a very interesting style. This is the tutorial, but let me see if I can pull it up. Oops. Let me grab it. Where is it? Game doc. Ah, here it is. Cool. So the game we're trying to make, making it for a friend of mine, is based on a retro game that you can play on this website. Kingdom Crusade. So my friend's an artist, and this is his concept. He's going to make this a demon variant of this game that's based on like chess pieces, like pawns and queens and knights type characters. It's going to instead be more, not gory, darker themed, right? And the perspective is very, I don't want to say unique, but like it's not just like, oh, it's top down or something. It's more than that. Let's look at it. Skip ad, please. Skip ad. All right. And yeah, these graphics are dated. Obviously, we're going to modernize them a bit, but we're still going to try to do some pixel art. Forget the controls to operate this. There we go. Select world. So there's two modes. This one is top down. So this is the player like select, but it's actually live right now. The enemy, so you're battling the guy in this gray area. He's trying to take over your kingdom. You're trying to take over his. Like you can see he has a guy up here in this castle. So he may come over to my castle and try to steal it. And I can defend. I right now have a giant in this castle. This is a wizard. This is a queen. And each of them has like different movement styles, different weapons, different health, whatever, right? And so you also pick up item stuff, but this is the top-down screen, the map selection. So top down, we can do this, no problem. The one I want to start with, though, is when you select your character, which I just hit X. There we go. This view, what would you call this, right? It's not top down. It's not platformer 2D style, right? Because you can go up and down, but then the perspective of like the tree doesn't change. I looked it up. I forget. It's also got a unique way of moving the screen, right? Because it doesn't quite follow you if you're on the right edge of the square. It's just kind of static. The screen's not moving. But then as soon as I get to like the middle point or something, or far enough away from the edge, it does start to move the screen. See, it follows the player. The player stays in the middle of the screen until you get to the edge of the left side of the screen, right about here. Now the player moves and the screen does it. Isometric, thank you. That's the term I was looking for. But it's not actually, I don't think it's isometric. Isometric is like Diablo style, right? We can look. Maybe it is pure isometric. I'm just being crazy. But I feel like isometric is more top down. That makes sense? I guess that maybe there's different angles for isometric. Maybe it is isometric. Like, I was thinking more like Diablo. Let's see what comes up. Yeah, Diablo. Let's see. Is that the same? Because you got a lamppost here, and the world doesn't change, and you move. Oh my god, is it just isometric? Sort of isometric. What's the difference here? Compare the two. I mean, obviously, scale and stuff's different, but like, I feel like the ground is just like completely ramped. But here, I think it's just the angle. I think it's isometric at a different angle. Okay. All right. That's going to help me find better examples. But anyways, so it's kind of unique in that regard. It has two views, that the top down one and the isometric one, but also in the movement where the screen moves or doesn't move, but also it has the screen flip. Let me show you that. So remember, I'm actually in one square, but they're all connected squares. So if I move all the way to the left, it flashes the screen, and now I'm in a different square. And if I try to get back to the map, if I can remember what button that is. No idea. There. So I moved over one square. Started there and moved over here. And you can just keep moving left, move right, move up, move down. But every time you leave your square, it flashes and kind of loads the next one, and you're starting on like the right side of the screen because you came from the left or whatever. And so that whole design of a map is kind of unique, I would say, or at least you're not going to find a bunch of, 2D game development tutorials that have that style. So we're going to have to use our brains a little bit to come up with that movement and map and all of that. But anyways, we're getting ahead of ourselves. We're just doing a very, very basic tutorial here in Godot. Thanks for tuning in, guys. It's nice to have a pair, even if you guys are just faceless names in a chat. All right, here we go. The Boolean assignments in the code above are common shorthand for programmers since we're doing comparison test Boolean. If you guys got any questions about this code, let me know. It's very, very, very basic stuff. Play the scene again and check that the animations are correct in each of the directions. A common mistake here is to type the names of the animations wrong. We already handled that. It's good. Yeah, man. Well, thank you. When you're sure the movement is working correctly, add this line to ready so the player will be hidden when the game starts. All right, there's also one other thing I want to fix, which has just been bugging me. And that's where he starts. He starts at the top left corner. I don't like that. So we're going to fix that. So right now our scene, what's really interesting about the Godot engine is that everything is a scene. What you would normally call a prefab, like a player is just like an instance of a player class. It's actually the scene right now. So it's the only scene I have. So it's a little weird, but like I can run the player scene and it just puts this player model in this little rectangle. And you can have scenes inside of scenes inside of scenes. Like everything is a scene. Oh, nice. How's Cody AI? I don't think I've tried that one. What is it? Been using a lot of AI tools myself lately. I even looked up GPT for Godot, but it was pretty slow. It's easier just to read the docs. All right, so I want to move this. You can see a little blue outline here. This is a vertical screen that we set up at the beginning of the tutorial. You can't really see the left line, but it's this green one. Let me move it. Let's see if I can move it. I might not be able to because it had me lock it. There we go. Okay. Had me lock the children, but I think that's fine. Because they're all nested. All right, there we go. In the middle of the screen. And then it says it wants to hide it by default. So let's go back to our script, which, funny enough, it's right here. Okay. I was going to say, it doesn't actually show in the node window or whatever. And this is on ready, they said. Was it hide or hidden? Hidden equals true or hide? I think it was just like a function that said hide. Yeah. Okay. Then how do you unhide? What is Cody AI? Like I've heard of it. There's been so much stuff out there. AI code assistant. With any language. Cody answers technical questions or writes code directly in your IDE using your code graph. I wonder if so I usually use JetBrains IDEs, and I've used their code assist, which is really good actually. CodeGPT, Copilot is good. Code fast with AI assisted autocomplete. Yeah, I miss Copilot when I'm not in JetBrains. Cool. Cody is available in JetBrains. I wonder what it offers that the others don't. I know it gives you context. Oh, I know what this one is. My coworker was using this. No, but he was using with Visual Studio Code. His called something else too. I don't think it was Cody. Well, he was kind of bummed out that he had used Visual Studio Code because he's used to JetBrains. I wonder if will give him what he needs. So you can add context, like by adding a file. The thing about JetBrains' assistant is you can just give it context by pasting the code. It accepts like thousands of lines of code and it just works. Or you can reference the currently open file, or supposedly just give it a file name, but if it's not actually open, it won't have the context. It won't be able to read the file. It's kind of weird. Is all the code you were writing strictly for the character we are seeing move around, like that hide function would only ever hide? Yeah. Using to start writing a collector card game. Oh, sick, man. One of the first things I ever tried to code as a kid was a Magic the Gathering ripoff in Visual Basic. I don't know if you guys ever heard of that, but it was like one of the first no-code platforms before no-code was a thing. But yeah, I didn't get very far. But that was, I always liked the idea of collectibles, card games and stuff. But now, of course, Magic has an official game. So the thing that I'm programming, I specifically added this file here. It's called PlayerGD, which is a Godot script. And that's this language here that's kind of looks like Lua or Python. I've only ever used Python, not Lua, but it's got some custom stuff in it, like this $ symbol, which just looks up attached nodes with this name. So you'll notice under the player, I have another thing called Animated Sprite 2D. That's where I put the different animations. And then collision is what's going to handle. There's no visual indicator. Oh, there is a visual indicator of that. It's here. See this little guy? This is the collider. This tells it where other colliders can actually come in contact, and then we'll get like an event that says they've hit. I haven't gotten that far in this tutorial yet, though. Matthew Berman did a video on it, but using llama code. Matthew Berman, let me check it out. Check that out. Yeah, who was it? Was it Llama's Facebook, right? Meta. What was the Google one? Google's talking about how they have a new coding AI that they think is going to be a Gemini, I think. But I've been so unimpressed. I usually love Google, but I've been so unimpressed with the Google AI stuff that they've released. It's just been so far behind OpenAI and Microsoft. But if it's good as they say it is, like the good models that they're not letting us have yet, then I don't know, they might take back the market. We'll see. Berman. I'm watching a lot of YouTube. I don't know if I've come across that guy yet. I am not subscribed. Okay, I'll check him out later. Cool. Yeah, sometimes I do streams on different AI tools. Like I did one on text-to-speech. Yeah, text-to-speech, different tools. Ended up using OpenAI's Whisper API, which is really cool. Yeah, I've had too many side projects, man. I haven't made any progress on this game. I first was doing an Unreal Engine, and it's just like overload, too much crap. I've used I used some other engines in the past, Unity obviously, which is dead in my book, with their stupid pricing thing. And then the only real games that I've ever like finished, almost all of them, or maybe all of them, were done in Game Maker, which is so much like Godot. Like it's so simple to use. Like there's a lot of complexity to it once you unravel it, but it's pretty easy to get into it, I think, right? Low jumping off point. But then everybody started going crazy with the different pricing models. So the fact that this is open source, totally free, is just insane. Alex Zinsky. I should find the guy that I usually watch for AI, like just like, here's the latest tool, look what this thing can do. Zinsky. I subscribe to him as well. The problem is I think I follow like 1,000 people, so I don't even know if I'd be able to find it. Subscriptions. Let me see if it just pops up in my feed real quick. Doesn't look like it. Yeah, not sure. 7 hours ago, major AI news. Sam Altman, AGI shocker. That later. Matt Wolf, is that the guy?
You hear about really cool sport.
That is a guy I'm subscribed to, Matt Wolf, with the E. But that's not the one I was thinking of. Like Fireship, that guy's hilarious. If you ever watched those videos, web development. Yeah, well, I'll post it if I can remember, but yeah, don't see it. I found you by asking for live development right now. That, you know, I'm so glad that I changed my freaking category. I had it set to Pal World, you know, that Pokemon knockoff game yesterday during my stream. And so then I finally changed it today. And I normally do just chatting because I never could find a software development one. But then today I just searched again and somehow, yeah, software, I think it's software and game development or something like that. I don't know. Perfect one. Yeah, Fireship is funny. It's hilarious. Yeah, well, murdered your math's better than mine. I'm so rusty. All right, well, let's get this thing. Okay, so it's hidden by default. Where does that leave us? How do we unhide this guy? Oh, I messed up my windows. I got 3 monitors, and I swear Chrome is so annoying trying to find the windows you've lost. All right. Power World, this is insane. I would say it's the game that the Pokemon company should have made when they made Pokemon, but it's too out there, too crazy with the guns and stuff. But just the survival mechanics are pretty addicting. At least I've always liked those types of games like Rust, and even the Lego Fortnite is pretty sick like that. So it's a good hook, just that stuff alone. Collected Pokemon and use them to build your base. Like, come on, that's awesome. All right, hide, preparing for collisions. We want player to detect when it's hit by an enemy, but we haven't made any enemies yet. That's okay, because we're going to use Godot's signal functionality. So if anyone's familiar with like observer pattern, that's what signals are here. Add the following at the top of the script. If you're using GDScript, add it after extends area 2D. If you're using C#, which I'm not. All right, signal hit. This defines a custom signal called hit. We have our player emit, send out when it collides with an enemy. We'll use an area 2D to detect the collision. Select the player node and click the node tab next to inspector tab to see the list of signals the player can emit. Notice our custom hit signal is there as well. So here, since our enemies are going to be rigid body 2D nodes, we want the body entered body node 2D signal. This signal will be emitted when a body contacts the player. Click connect and connect the signal. So body entered. Godot will create a function with the exact name directly in script for you. You don't need to change the default settings right now. If you're using external text editor or bug currently prevents Godot from doing so, you'll want to set your external editor, but the new function won't be there. In this case, you'll need to write the function yourself. All right, so let's go ahead and add the signal and then add body entered from area 2D. All right, I think it was up here, right? Signal hit. Save that real quick, and we'll go look at what this thing's talking about. So signals are these different, it's kind of like pub sub to like, or events. Where was that menu? I saw it the other day. Here it is. So there's our signal, which we can tell other people who care that we've been hit, but what we want is from area 2D, I think. Area 2D, they said, entered, area entered. Yeah. And so what this is saying is if I just use the defaults, it will add it to my code for me. In this case, just the function name and the property or a param that it takes. It's not actually doing anything. All right, what do they want us to do with this? Body has been entered. Yeah, it'd be cool if it said you've been bodied. Note the green icon indicating that a signal is connected to this function. Oh yeah, cool. I didn't even see that. So if I click that, it takes me here. Target player, signal entered, source player. Note the green icon indicating the signal is connected to this function. This does not mean the function exists, only that the signal will attempt to connect to a function with that name. So double check that the spelling of the function matches exactly. Next, add this code to this function. So we want to hide it when you get hit. We're already hidden, but okay. And then you want to admit on our signal that we've been hit. And then we want to get our collision and set some property called disabled to true. Set deferred. Why deferred? Must be deferred as we can't change physics properties on the physics callback. Okay, that makes sense. So other game engines have like game engines, app development frameworks have like specific life cycle events that you have to do things in. This one's just like, I guess, I mean, this, you would have to know that this is like a physics signal, like this function is physics related, that you can't just set this. You probably get some kind of error. We should actually test what happens if you just set it immediately instead of deferred. I'd be curious to see the error. Yeah, Red Dragon, you wonder if you can point the docs at, or point Cody at the docs. Let me know how that works, man, because I tried that once. I think I have a stream on it, actually. I pointed it was I tried a couple times. I tried like a different custom ChatGPT plugin that reads code. And like I pointed at like I think it was for a cross-platform app framework, Kotlin or something. And I pointed at the repo and I said, and I asked it questions about it, like, what do you know about this code base? And like, how would I do this in this code base? And it would have to make queries to the data. It would fetch, you know, certain files, and then it would try to answer my questions, but it was really slow, clunky, didn't have the data it needed. So I've been working more and more with LLMs, and you really need purpose-built, or at least need access to some sort of embeddings or even a vector database of the data that you want to query. Because if you just give it access to a new website that's never seen before, in my experience, it hasn't done what I wanted to do. But I'd be very interested to see how Cody behaves in that regard. Let me know. Yeah, it's only a matter of time before there's like a purpose-built LLM for everything, you know, so that it's like all these Godot docs are embedded, and like there's like an ETL that ingests them nightly or something. Every time they change, it gets a push and the vector database gets updated or something like that, you know. Once that stuff becomes like super easy and everyone can just do it, then yeah, that's basically the new Google search. All right, each time an enemy hits the player, the signal is going to be emitted. We need to disable the player's collision so we don't trigger hit signal more than once. So it can cause an error if it happens in the middle of the engine's collision processing. Using set deferred tells Godot to wait to disable. So it might not error if I don't use set deferred, but it might. Okay, so we're probably not going to be able to see the error necessarily. All right, hide, hit emits, and then set deferred on the collision shape. Let's try it. And I close this window. Hide. One thing I missed my ID for is it moves your cursor to the outside of the parenthesis for you. Hide. Emit on hit.emit. And then what was the next thing? Collision. All right. Please autocomplete because I don't remember. There we go. Collision dot This is the deferred thing. Set deferred. Okay, setting deferred. Some value is false, but what value? Visible, I think. Is it visible? False. Let's see. Enabled, false. Disabled equals false. Okay, I totally did that wrong. Oh wait, no, I'm looking at the wrong thing. It's up here. Oh yeah, disabled, true. Okay. Disabled. Look at comma. It is. Interesting. Interesting. And then it's in quotes. Nope. This one's in quotes. Let's see how good this editor is. Hey, it did it. It wrapped it for me. Alright. Disabled is true. Cool. I know I could just copy paste it, but I want to like get it in my head. Alright. Yeah, I tried running my own. Are you talking about running your own model, or just in general running Kodi is hard on a Windows machine? It turns into a vacuum. Yeah, yeah. I barely touch my gaming machine these days because all the cool tools are like Linux or Mac native now. So, though I hear there's some really good gaming cards that help with AI. Alright, with the player working, we'll work on the enemy in the next lesson. Let's knock this out. Now it's time to make the enemies our player will have to dodge. Their behavior will not be very complex. Mobs will spawn randomly at the edge of the screen. Choose a random direction and move in a straight line. We'll create a mob scene. This is what I'm talking about. So it's like the player object, but now it's a mob object, but they call it a scene. Which we can then instance to create any number of independent mobs in the game. So it's like a prefab. Node setup. Click scene, new scene from the top menu and add the following nodes: rigid body 2D, animated sprite 2D, collision shape 2D, visible on-screen notifier is the only new thing. Don't know what that is. Don't forget to set the children so they can't be selected. Okay. Link like you did for the player scene. Select the mob node and set the gravity scale property in the rigid body 2D section of the inspector. Choose 0. So no gravity because this is like floating in space game, I think. This will prevent the mob from falling downwards. In addition, under the collision object 2D section, just beneath the rigid body 2D section, expand the collision group and uncheck 1 inside of mask property. This will ensure the mobs do not collide with each other. Why would the mask prevent that? Oh, because it's on collision object 2D. Oh, right. So the collision object is going to collide with our player, and our collider, like our signal for hit, is going to be called. But if these two collide, apparently there's, I guess mask means there's like physics on it. Not sure. Yeah, it's so simple. I feel like this game engine is exactly what you would kind of think it would be. I'm very impressed with it so far. And then set up the animated sprite 2D like you did for the player. This time we have 3 animations: fly, swim, and walk. There are 2 images for each animation in the art folder. The animation speed property has to be set for each individual animation, adjusted to 3 for all 3 animations. Oh, interesting. 3 FPS. Okay, let's see how much of this I can remember. I'm going to make a new scene called Mob. It's going to be a rigid body 2D. Oh, this one's a rigid body. Was mine a rigid body? Player. What was player? It was an area 2D. Okay, that's why I didn't have to turn the mask off for the player, because it was a different type. All right, rigid body has physics on it. That's why. Okay, makes sense. A rigid body 2D mob, animated sprite, collision shape, visible on screen, and then there's some gravity scale thing that I have to turn off, and mask I have to turn off. All right, I'm not gonna remember all that, but rigid body 2D, rigid body 2D. New scene called mob. Oops, rigid body 2D, and we'll call it mob, and it's under the player. It's not what I wanted. Oh, I know why, because I didn't say new scene, I said new node. That before too. You will die. Bye. All right, new scene. New scene. 2D scene. Nope. We'll just go rigid body 2D again. Now we call you mob. All right, let's see if we can remember what we have to turn off. Oh, first we're going to add those nodes. Animated, collision, what else? Animated 2D, collision. And there was something about like on, oops. I need to turn this off. Cannot be selected. Gotta open this scene. Unsaved. Save. Save. Cool. And then I have to turn this guy off so I can't select the children. Now I can add a node. Collision shape 2D. Something about side of the screen. Something's notifier, screen notifier. Visible on screen notifier 2D. I think that's what it was. Okay. Rigid body, we need to turn off some stuff. Let's turn off. Gravity scale should be 0 so they don't fall down. And the mask on the collision shape should be off. The mask is under visibility. Light mask 1. Visibility layer. Was it light mask they said? Let's assume it was light mask. Let's check. Ooh, this one. Collision layer mask, not light mask. Oh, that sounded weird. There's a collision. Where's collision? Am I blind? We got transform, visibility, ordering texture material process. Am I on the wrong thing? Does this guy have collision? It is the rigid body, so I guess that makes more sense. Yeah, there we go. Uncheck the mask. I wonder, yeah, so these must be like layers that you can collide with. So like if I set this to 4 and then I made another rigid body that's also 4, they would hit each other. I don't know what's the difference between layer and mask though. I know it can get complicated when you have a lot more objects. Okay, I think I got all that. What did I miss? All right, gotta set up the sprites for fly, swim, walk, and the speed should be 3. So there's like an animation window down here, I think. No, where is it? How did I get there last time? Oh, I have to choose the sprite frames, new sprite frames, click it again. Now it opens. We'll make this one swim because I can't remember any of the other ones. So then we got enemy swim. And we set it to 3 FPS. And another one for walk. Oh, do I have to set this for both? 3. Like this one. No, good. They're both set. Okay. And then one more for fly. Yep, I definitely messed something up there. I was filtering, that's why. Delete you. Go away. Fly. Fly alt? Why is it alt? Maybe they just changed the graphics. Alright, also 3. Cool. This shouldn't do anything if I play this scene, right? I'm just gonna sit there. Okay, that's what I thought. What's next? You can use play animation buttons. Oh. On the right of the animation speed input field to preview your animations, we'll select one of these animations randomly so that the mobs will have some variety. This time we have 3 animations. So fly, swim, and walk are the 3 variations. Okay. Like the player images, these mob images need to be scaled down. Set the animated sprite 2D scale to 75. As in the player scene, add a capsule shape 2D for the collision. To align the shape of the image, you'll need to set the rotation property to 90 under transform. Okay, let's do that. Transform, rotation, 90. Flipped it. And we need the capsule. Where's our little capsule? I remember how I added that. Let's look at the other one. Layer. Collision object. I don't even see the capsule here anymore. Center collision? No. Oh, I have to look on animated maybe. There we go. Sprite frame, speed, transform. No capsule. All right. Good night, Murdered. Thanks for watching, man. Good talking to you. You have to add a capsule shape 2D for the collision. How do you add it? Add capsule shape. Capsule. Maybe just add here. Capsule shape 2D. Okay. Yeah. Oh, I just added to the same guy that already had one. Oops. How do I delete it? I just literally create 2 of these. I don't even know where these things go when I create them. So if I move this, it's changing the transform. Oh, red dragon left. Sorry. Yeah. If you guys, yeah, man, I'm all about noob. I used to have a channel on YouTube called Noobs Do It Best because I just have a habit my whole career of just like changing to new tools, trying new stuff, always being the noob. But I don't mind asking dumb questions, looking stupid, you know, because I think that's the best way to learn. It's awesome. All right. It doesn't help though that I do this when I'm freaking tired. All right, animated sprite, collision capsule, add collision capsule 2D, capsule shape 2D. Okay, you're added, but this guy like I did the other one. Oh, I realized I never changed the size. Did I lose the capsule? Oops, I'm way zoomed out. Center of the screen is over here. And yeah, it's too big. Okay. Let's fix that first then, I guess. This was scale. 0.75 tab. Okay. Still feels big, but all right. And I'm still lost on the collision capsule. I must be missing something about this UI, like there's another tab or something right in front of my face I'm just not seeing. Let me try adding it one more time. Maybe it didn't save. 2D capsule shape used for physics collision. It's recent. I can't tell if that actually did anything. Let's increase the radius and see if I can find it. Am I blind? Is it this guy? It's not that guy. Where is this? Let's go look at the player one more time. So is the capsule on the player or is it on the animation? Or the collision? Maybe it's on the collision. Collision shape 2D. There it is. Okay. It's on shape. Ugh. Okay. You know, I see. So then we go to collision, shape, new collision gap. Okay, so I don't know what was happening before when I kept just saying new collision gaps a little earlier. Ooh, what's the size? How do I do this? Do you have an example? Yeah, this is GD script. I might go to C# if I stick with this engine and want to like have reusable classes and stuff, but I think I used to really hate scripting languages. I was all about object-oriented programming, but now I'm just like, whatever tool gets the job done, it's cool. Not as opinionated as I used to be about those things. Doesn't have a screenshot of what the capsule looks like. So, is it important that the ears are touching? It's probably not good that it's outside the bottom like that. I'm thinking we go like this. Like, okay, if you get hit by the ear, nothing happens. But that's better than like it touching you on the bottom where it's not even actually touching. So we'll go with that. Save the scene, add a script to the mob like this. Okay. This is gonna extend, or it already extends. Now let's look at the rest of the script. In ready, we play the animation, randomly choose one of the 3 animations. So mob types becomes all of the sprite frames names. And then you play a Randy. That's my name. Random types dot size. Ooh, a module. Modulus. What do they call this? Mod. We'll call it mod. Mob types dot size. Okay, so it randomly picks one for this array of mob types. Okay. Let's copy this. I'm tired. Not metadata. I want to add a script. New script. Mob. This isn't ready. Just going to set up. You're going to be a random animation. Which one are you going to be? Save. Look at that guy. If I regenerate, it should be a different one potentially. Same one. I don't know if it's got a seed. There we go. Different one. So you're doing some weird exercise. Cool. First, we get to list animations. Yes. We know. Thank you. The last piece is to make the mobs delete themselves when they leave the screen. Connect the screen exited signal of the visible on-screen notifier 2D node to the mob and add this code. Queue free. This completes the mob scene with the player and enemies ready. In the next part, we'll bring them together in a new scene. We'll make enemies spawn randomly around the game board and move forward, turning our project into a playable game. Okay, queue free, I guess. Screen exited signal on the screen exited. Okay. Does it already have that or not yet? Looks like it doesn't have it. Oh, here it is. Screen exited. Screen exited becomes what am I supposed to connect to? Make the mobs delete themselves when they leave the screen. Connect the screen exited signal to the visible on screen notifier node to the mob. Okay, mob. Just this guy, I guess. Yeah, there we go. Clear queue. So I forgot. Queue free, because that makes sense. Queue, such a weird word. Free. Alrighty. Let's connect these dots. So close. I guess we still have a HUD to do. Oh, all right. It's getting hot in here. Can you drop a link to that project tutorial when you have a second? Yeah. Actually, you're on Twitch or YouTube? You're on YouTube? It's cool. Getting some YouTube traffic. Oh. All right. Now it's time to bring everything we did together. Create a new scene and add a node named main. The reason we are using node instead of node 2D is because this node will be a container for handling game logic. It does not require 2D functionality itself. Click the instance buttons represented by a chain icon and select your saved player scene. Okay. This feels good. Finally building a real game. Scene, new scene, not 2D scene. Node. There we go. Call it main. Oh, capital or not capital? I think they don't use caps here. Well, they did. Cool. Nice. Maybe if I stream more consistently, they will show my videos in the search results. Okay, link. We're doing the link. Player. So we should get an instance of player. Nice. And now add the following nodes as children to main and name them as shown. Values are in seconds. So add a mob timer, a score timer, and a start timer. How often mobs spawn, increment the score every second, and give a delay before starting. So you get points for staying alive, I guess. And marker 2D for start position to indicate the player's start position. All right, 3 timers and a marker 2D. Mob timer, score timer, start timer. There we go. Score timer. Start timer. What was that other thing called? Marker? Yeah. Okay, how do we use these? Set the wait time property of each timer node as follows: 0.5, 1, and 2. Oops. Still getting used to this keyboard. Alright. Was that 0.2 or 2? No, this one's 1 and this one's 2. I think. 0.5, 1, 2. In addition, set the one-shot property of start timer to on and set position of the start position to 240 by 450. Where's the start position? Oh, marker 2D. I was looking at the wrong thing, that's why. 240, 450, something like that. Yeah. Spawning mobs. The main node will be spawning new mobs, and we want them to appear at random locations on the edge of the screen. Add a path 2D node named mob path as a child of main. When you select Path 2D, you will see some new buttons at the top of the editor. Select the middle one, add point, and draw the path by clicking to add points at the corners shown. To have the points snap to the grid, make sure use grid snap and use smart snap are both selected. These options can be found to the left of the lock button, appearing as a magnet next to some dots intersecting lines respectively. Draw the path in clockwise order, or the mobs will spawn pointing outwards instead of inwards. Interesting. Okay, so where's the first dot? Is it in this corner? When you select Path 2D, you will see some new buttons at the top. Select the middle one for add point and draw the path by clicking to add points at the corners. Okay. Doot, 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 doot. And we want these turned on. Okay. What am I calling this thing? Mob path. It's pretty cool. Gonna turn on magnets. Zoom in a bit. Use my other mouse. Click and drag. I wish they would make that blue easier to see. All right, add point. This one. Click. Click. I feel like that made a line. Did I click the wrong thing? Add point. What did I do wrong? No, because they said clockwise, so I think it does have to be directional. Let's see. I guess they're just zoomed out. I don't know. Maybe this is from an older version of the... Oh, what's 5? 5 must be... Complete the circle? Complete the square? Select control points. Is that what he clicked? No, it's not that one. It's this one. Select points. Shift drag, select control points command. That didn't look right. After placing point 4 in the image, click close curve. Yeah, that's what I thought. They were trying to do something like that, but that icon looks different. Where's close curve? Oh, it's over here, isn't it? Where is it? This one? Boom. Done. Okay. Yes, thank you. Close curve. Didn't see that. Now that the path is done, oh, I was turning on my air and I forgot. Room has the worst conditioning. It's either too hot or too cold. $70 degrees. It's cooking. After placing point 4, and we did that. Now that the path is defined, add a path follow 2D node as a child of mob path and name it mob spawn location. This node will automatically rotate and follow the path as it moves, so we can use it to select a random position and direction along the path. Your scene should look like this: mob spawn location, path follow 2D. This guy. Mob spawn location. This is mob path. Okay. Let's see, does it look like that? Player, mob, timer, score, timer, start position. Start position. Position. Okay. mob spawn location, mob spawn location. Main script. Add a script to main. At the top of the script, we use export var mob scene packed scene to allow us to choose the mob scene we want to instance. Cool. Packed scene. At export. Packed scene. Mob scene. Scene equals packed scene. Something like that. Is that a thing? Oops. Yes, except it's not equals. And I got a score here. Click the main node and you will see the mob scene property. In the inspector under script variables, you can assign the property's value in two ways. Drag mob scene from file system doc and drop it in the mob scene property. Click the down arrow next to empty and choose load. Select mob scene. Next, select the instance of the player scene under main node in the scene doc and access the node doc on the sidebar. Make sure to have the signals tab selected in the node doc. You should see a list of the signals for the player node. Find and double click the hit signal in the list or right click it and select connect. This will open the signal connection dialog. We want to make a new function named game over, which will handle what needs to happen when a game ends. Type game over in this receiver method box at the bottom of the signal connection dialog and click connect. You are aiming to have the hit signal emitted from player and handled in the main script. Add the following code to the new function as well as new game function that will set everything up for a new game. All right, let's see how much of that I remembered. Oh, first off, I have an error here. Export var mob scene pack scene. Export var. That'll do it. All right, and then we were. There's two things. I want to do the mob scene thing first. Right. So on this script, how can I set the script process? Mob scene. There it is. Load mob. Okay, and then player. Or we want this on main, I think. No, I'd hit player, signal, hits. And then I want this to be on main, on player hits. And then on player hits needs to do game over or something like that. And then there's like two functions. Game over. That's how they name their functions. It's so ugly. And func start game, I think it was. And then I'm pretty sure ready needs to call start game. Where are you at, Murdered? What city or state or country? It's not even that hot outside where I'm at. It's still winter. Let's see. Select the instance of player under main, scene doc, no. Signals to we did all that. This is what we're looking for. Game over, score timer dot stop, mob timer stop, score equals 0. Ohio, Ohio, Ohio. There a couple times. Score equals 0. Score equals 0. Player start. All right, so we're getting the player, we're calling their start function, and we're passing it the position. Position is of the marker. Makes sense. And then we're starting the start timer. So get the player, call it start function, pass it the start marker's start position. So start position dot position. Is that what it was? Oh, yep, looks like it. And then start timer. Start timer dot start. Cool. Now connect a timeout signal of each of the timer nodes, start timer, score timer, mod timer, to the main script. Start timer will start the other two timers. Score timer will increment by score by 1. All right, so on score timer timeout, score plus equals 1. Let's just do that first because I'm not exactly sure how to connect these. I have an idea of how to connect these. So we go to start timer or score timer. We'll do that one first. Timeout. Put it on main. Connect. Score plus equals 1. So what is this? Plus equals 1 on score timer timeout. Yep. And then the other one on start timer is where you start the mob timer and the score timer. Start the mob timer and the score timer. Start the mob timer and the score timer on the start timer. Yeah, that makes sense. Mob timer and score timer. Mob timer dot start score timer dot start. Makes total sense. Play. Crash. Start in base area 2D player dot GD invalid call non-existent start. I was wondering about that. I don't remember putting a start function in player. That's coming up. In on mob timer timeouts, we will create a mob instance, pick a random start location along with the path 2D, and set the mob in motion. The path follow 2D node will automatically rotate as it follows the path. So we will use that to select the mob's direction as well as its position. When we spawn a mob, we'll pick a random value between 150 and 250 for how fast each mob will move. It would be boring if they were all moving at the same speed. Agreed. Note that a new instance must be added to this scene using add child. All right, I am going to copy this because it's late, but I'm going to read it. So this was in on mob timer timeout. So I need to do timeout, add that, and then we can paste this guy. Okay, let's read it. So create a new instance of the redo. Okay, create a new instance of the mob timer. Mob scene instantiate. Oh, it's the first time we're seeing instantiate. Okay. Mob scene instantiate. Mob scene instantiate. Okay. This is the mob spawner guy, right? That's just creating an instance of one mob. Okay. Choose a random location on path 2D. So mob spawn location, mob path spawn location. Where did we get mob spawn location? Oh, that must be the 5 points we added. Mob spawn location dot progress ratio random float. So that's how far along its progress it is. Okay, so it's putting it somewhere along the path, I guess. Set the mob's direction perpendicular to the path direction. Direction mob, spawn location, rotation plus pi divided by 2. Direction is rotation. I'm going to leave this comment because this is confusing. Perpendicular to the path direction. Okay, cool. So if it's on this path above, it will go down. If it's going like this, it will go left. I still don't know how it turns inwards. That must have been the clockwise thing we did. I bet you if we did like -2, it would go outward. All right, set the mob's position to a random location. Spawn location. Progress ratio, random F. Add some randomness to the direction. This is the fun factor they talked about. Random F range, pi 4 by 4. Direction. So they already said the direction, now they're plus minusing some direction value. And it's a 2D vector. All right, mob rotation equals the direction. Choose the velocity. Choose the velocity for the mob. Velocity. It's a random float range between 150 and 250 and 0. Random float range between these. Oh, and so the second velocity is always 0. Why? 2D. So this is only going to move it in the x direction. Linear velocity, velocity.rotated direction. Spawn the mob by adding it to the main scene. This is where the add child. So we instantiate it, but it doesn't actually show up in the scene until you add child. Okay, cool. Pretty sure this is still gonna crash. Alrighty, why pi? Good question. Why pi? Something to do with circles, right? At least we're not dealing with trig anymore, right? Let's see. In functions requiring angles, Godot uses radians, not degrees. Pi represents a half turn in radians, about 3.1415. There's also TAU, which is equal to 2 times pi. And you're more comfortable working with degrees, you'll need to use the degree to rad and rad to degree functions to convert between the two. Fun. Let's test the scene to make sure everything is working. Add this new game call to ready. I'm still going to figure out that start function that we're missing. Ready. I already did. See, I was ahead on that one. Let's also assign main as our main scene, the one that runs automatically when the game launches. Press the play button, select main scene when prompted. If you had already set your other scene, means that I did not. So let's do that. Select current scene. Yes. Great. And then crash. You should be able to move the player around. Okay, so I definitely missed something. Where was the start call? Start function. The previous page must have been. Start. No? So where was it? Did I just make that up? Did I hallucinate? Am I an AI? Tell me I'm not crazy. Here it is. So in new game, player start. Let's just make sure I didn't typo this. New game. Did I put it in the wrong one? I put it in the wrong one. That's start game. Is there no start game? I just named it wrong. Is that what happened? Okay, score 0, start position. But that's still not why it's mad, right? Isn't it mad? Because player.start doesn't exist. So this is still going to fail, right? Yeah. Start game. Not found. Am I going insane here? Did I put this in the wrong object? Did they not tell me to add an... Oh my god. Said I already did that. I already did that. Yeah, I already did the wrong thing. This is why you don't jump ahead. There's a lesson for you kids. Okay. Alright, start. Okay, still fails there. So let's go to player script and see what's going on with that guy. What? The scripts? Oh, I'm on the wrong thing. Okay. Alright, so there's no start function. Is that right? What do we have? On area entered. Process. Ready. We just don't have start. You know how I was like, man, why is this always hidden? I feel like we skipped a step where they unhide it. Let's go back until we can find it. Coding the player. Coding the player. We're looking for start. So that's where we hit it. On-bodied entered. There it is. The last piece to add the function we can call to reset the player when starting a new game. Somehow missed that. Shift tab, please. Thank you. Tab. Save. Stop. Run. Moment of truth. Okay, okay. Oh, guy's gonna kill me. Oh, I didn't die. Okay. So the collision's not quite right, and we don't have the HUD yet. The HUD's the next part. So what's up with the collision? Oh, I did not get called. Alright. Preparing for collisions. What did I miss in here? Let's see if I got a body entered and all that set up. So if I go to main, player, does this need to have any collision set up? Disable mode? What does that mean? Disable mode. I wonder if when I was adding all those stupid, what are those collision things called? Not these. Where is it? These capsules, if that messed anything up. Disabled, one way. Alright, so we did body entered on what script? Main or player? I think this is player, right? Yeah, we're in the player scripts. We did the hide. We have a signal for hits. Then we've got this body entered. Notice our customer. Okay, body entered. Cool. Hide, hit, emit. Am I missing something there? Hit, emit, set deferred, disabled true. Hide, hit emits, set defer, disable true on the collision shape 2D. Looks right, but I mean, I've been typing and reading things wrong all night, so. Looks right though. Start position, collision shape 2D equals false, so it might have been disabled before. But I added that now, so that's not the problem, right? Start, disabled, false. We know the show is getting called, so it's definitely calling that. Let's add a log. Let's just add a log, right? When in doubt, print. Whatever. Hey, hit me. Okay, so they're not hitting me. So I'm never entering that. I might not have hooked something up. So if we go back to main, look at our mob spawn. I guess it would be on mobs. Mob. Ready. Play. Does that have a collision? Yeah, it does. What does it look like? This guy. We turned off that mask. Don't think that's the problem. I kind of want to turn it back on. See them collide with each other. What was that? Not transform. Material process editor. This is the capsule. Local to scene path. Physics material. Collision object 2D. Disable mode remove. Collision. Yeah, we turn the mask off. Let's turn this on. I want to see it. They hit each other. Let's see if we got some kind of collision. Yeah, see, they're hitting each other. So they have collision. They're not following our function. Why? Why would that be? So on collision, am I missing something? What could I be missing? What could I be missing? This guy's nothing. Okay. All right, so we could add like a collision here. I'm not going to do that though. What am I missing? Let's look at the enemy. Maybe there's a space. Okay, so we turn that off. Gravity's off. Animated sprite. We did all that. Rigid body 2D for the mob script. Is it a rigid body 2D? It is. So ready. Are we missing a ready? No. Mob types chooses the animation. We got that working. And then this queue free thing, which we never really understood. With the player and enemies ready, in the next part we'll bring them together in a scene. So it must be here where they collide. Spawning mobs. So we got the spawning working. That's great. Mob location, mob path, all that worked. Player is that mobs work on each other, so it's got to be the player. Yeah, totally. But I have this function, right? So let's walk through it. This guy has an on area entered, right? Which is supposed to fire anytime someone enters his area. And it would call this print log, which it's not. So why aren't they hitting? Or why aren't they entering this little thing, right? So where does this come from? Where's that on hit signal? Oh, on hit signal is emitted by this. But the thing that triggers this function, I added it by going to node signals and then looking for area 2D. Or maybe it was collision object 2D. Maybe I did the wrong event here. Was it on area entered? I think it was on area entered. Pretty sure. Let's go back and check. On area entered. On area. That's the enemy player. Starts. Oh, I got it wrong. It's the other way around. It's when bodies entered. How can that be? You're an area. Why would it be a body? Yep, thank you. Good call. See if that works. Okay. Still not working, but maybe it's the way I added it. Let's read that part of the doc again. So it says area 2D body entered. So let's get some signal called hit that we will have our player emit, send out when it collides with an enemy. we will use area 2D to detect the collision. Select the player node and click Node tab next to the inspector. See the list of signals. Notice our custom hit signal is there as well. Since our enemies are going to be rigid body 2D nodes, we want body entered. Okay, so it's saying a body entered my area. Okay, I get it. The signal will be emitted when a body contacts the player. Click connect, and the connect signal window appears. Godot will create a function with the exact name directly in your script. You don't need to change the default settings right now. Okay. And notice this is no longer a signal. Oh, look at the type is wrong. Okay, we're gonna do this again. We're gonna get rid of it. We're gonna connect the signal for reals. Okay, so node collision area on body entered. This one. Connect. And now it's connected. See this guy? Connected, supposedly. I don't know. I don't quite understand that piece. Where does funk come from? Let's see if that's all we needed. These die. Die. Hey! On area entered. Cool. Do that, it'll fix it hopefully. Yep. I don't know. The only difference is I called this area instead of bodied. So like I don't understand, like is it smart enough to know the difference? Like if I put this back to this, and if I just change this to body, like what's the magic here, right? Oh, that's all it needs. See? If I put the wrong word here, no, it still worked. What the heck? Save. Stop. It works. Okay, put a bad name. Save. Yeah, the name shouldn't matter. Maybe I forgot to save after I changed it to unbodied entered. That's the only thing that kind of makes sense. Yeah, as long as I'm not using this parameter, the name shouldn't actually matter. Okay. Either way, we know that's working, but it doesn't look like the game stops. Shouldn't the game... Maybe that's going to be in the next section. Was there an end game? There was a start game or new game. Heads up display. Final piece of our game needs is a user interface to display things like score and game over message. Okay, so we haven't handled game over yet. And a restart button. Oh, I should have told you this sooner, Murdered, but if you notice a lag between you and me responding, it's because YouTube, for some reason, I can't find the setting for it, is like 30 seconds behind. But Twitch is like immediate, just FYI. And then I also like to upload the stream as a VOD on YouTube, but condensed. I take out all the ums and the ahs and silences using AI, and I post those up. So you'll see like past streams posted as condensed streams, which usually takes like 25 to 40% of the video away, which is kind of cool. Okay, we're going to create a new scene called Canvas Layered, and it's going to be an other node. No, it's called HUD, and it's a canvas layer. Create a new scene called other node with a canvas layer called HUD. Canvas layer node lets you draw our UI. the rest of the game so that the information it displays isn't covered up by any game elements like the player or mobs. The HUD needs to display the following information: score changed by score timer, a message such as game over or get ready, a start button to begin the game. The basic node for UI elements is control. To create our UI, we'll use two types of control nodes, label and button. Create the following as children of the HUD node: a label button timer, score label message, start button message timer. Click on the score label and type a number into the text field in the inspector. The default font for control nodes is small and doesn't scale well. There's a font file included in the game assets called Zolonium Regular TTF. To use this font, do the following. Under theme, overrides fonts, choose load and select Zolonium Regular. The font size is still too small. Increase it to 64. Under theme, overrides font sizes. Once you've done this with the score label, repeat the changes for the message and start button nodes. Anchors control. Nodes have a position and size, but they also have anchors. Anchors define the origin, the reference point for the edges of the node. Arrange the nodes as shown below. You can drag the nodes to place them manually, or for more precise placement, use anchor presets. All right, so let's add this. Start with the canvas layer. Our other node scene, and then canvas layer. Other node scene, and then canvas layer. Other node scene, canvas layer. Scene, new scene. Other node, canvas layer. Okay, and this guy is called, does it have a name? Control something? Other node. Create a scene, click other node button and add a canvas layer named. Okay, so I had it right the first time. This thing is named HUD. It's up display. And then we're going to add a label. Was there a button in there too? I know we had a label. What else do we have? It's like 2 or 3 labels and buttons. A button and a timer. Okay, we got a button now. And a timer. Timber. Timer. Cool. Let's name these score label message. Start button. Yeah, start button. It's game time. Let's see, what was it called? Message timer. Cool. And then I wanted us to do that font thing, so we should do that. An inspector. Is it for the labels? Font, localization, focus, mouse, input. Order visibility process editor. All right, let's go back. Let's see. I click on text and type a number into the text field. And the inspector, the default font for control nodes is small. Theme overrides. Control fonts. Theme overrides on the control. So this is a control. Theme override is here. Fonts is here. And load. Fonts. Zolonium or something. And then what was the size? 64? 64. We look at this in the scene. Save. What does it look like? Yes, that's pretty big. Cool. Same thing with this guy. Theme overrides. Fonts. Load. I'm going to try quick load. 64. This is not a font. Okay. What about the button? Oh, I need to anchor them. Arrange the nodes as shown below. You can drag the nodes and place them. Was I supposed to put a label? Where do they say to name this dodge the creeps? They didn't. It's right here. Okay. Arrange the nodes as shown below. You can drag the nodes to place them manually, or for more precise, use anchor presets. So what is the anchor preset? Top, middle, 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 and then somewhere below that. Don't know how you get the start location. Okay. This is top, middle. What looks like a preset? This thing? Yes. So top, middle. That guy? Does that look right? Does look right, but didn't really move. Vertical alignment, horizontal alignment. That's not actually doing anything as far as I can tell. I have to type something. Oh, it definitely did something. Alright, let's move it. Why is this so gigantic? That cannot be right. HUD. 64. Oh. Oh, that's the wrong one. Maybe I put an extra character in this one. Font size, no, 64. Okay. Was it destroy all creeps or something? Jesus, is it just me or is this gigantic? Oh, it's not gigantic. Okay, there's the outline. I think I gotta make that blue line like bigger or something. All right. This one was in the middle. It also didn't move. Why are you not anchoring? Is it this thing? Ah. Anchor. Nope. It looks like an anchor. When active, move control nodes changes their anchors instead of their offsets. Maybe I should have did that. It's not very clear. Nodes have a position and a size, but they also have anchors. Anchors define the origin, the reference point for the edge of the node. Arrange the nodes as shown below. You can drag the nodes to place them manually, or for more precise placement, use anchor presets. It's a different icon. Yeah, the blue line is ridiculous. This icon. Oh, okay, middle. And how do I make this text wrap? Auto wrap. Word smart. See, I don't think it knows the bounds of the room. Maybe it does. Dodge the creeps. What's that stupid window? Okay. Dodge the creeps. Was it 3 lines? Probably was just 3 lines, right? No, 2 lines. Dodge the creeps. Why is it so large? This one's like centered. Really just put spaces here. Like that. Seems like that's what they did. Okay. And the button, I have no idea how I'm going to place it other than manually drag it. I guess this probably does have a font. Buttons can have font too, okay? Don't judge. 64. How do I undo that? think I moved something. This thing. What is that? Okay, there it goes. I'm just gonna manually move it up a little. Or maybe it should be in the middle and then offset down. I'm assuming this is the offset. Something like that. That's a big button. All right, add the text 0, set the horizontal alignment to vertical center, choose anchor, preset center top, message, dodge the creep, set the horizontal alignment and vertical alignment to center. That's probably how they did it then. Center. Let's see, do they have some kind of auto wrap? Yeah, auto wrap mode to word. There it goes. That's much better. Under control, layout, transform, set size X to 480 to use the entire width of the screen. I was wondering how they got the width, so you just set it. Under layout, transform, width should be, size should be 480x, size 480. Cool. Let me recenter that. There we go. Choosing your center, add the text start under control layout, transfer set X to 200 and Y to 100. Okay. I have to change that. Layout, transform. That was close. 177. 100. Choose the anchor, center, bottom. Yeah, that's my first choice. Messed it up though. All right, under control layout, try to set Y position of 580. 80. On the message timer, set the wait time to 2 and set the one shot to on. 2, one shot. Okay, now add the script. So we need a start game. Add script. So we got a new signal there. We now want to display a message temporarily such as get ready. So we add the following code, show message text, message.text equals text message show. Okay. Start the timer. We also need to process what happens when the player loses. The code below will show game over for 2 seconds, then return the title screen, and after a brief pause, show the start button. Cool. Show message game over, so it calls this function game over. And it sets the timeout, so it waits for the timeout. Then it changes the text to dodge the creeps. It shows that. Why didn't it say message.show game over? Because it timed out. It has to restart it maybe. Make a one-shot timer and wait for it to finish. Get tree, create timer, 1.0 timeout, then show the button. So that's like an inline timer. Interesting. This function is called when the player loses. It will show game over for 2 seconds, then return to the title. Yeah, we already talked about that. When you need to pause for a brief time, an alternative to using a timer node is to use the scenes tree's create timer function. This can be very useful in add delays such as the above code, where we want to wait some time before showing the start button. Add the code below to HUD to update the score. So when do we update the score? Oh, when time passes, right? Update score. The question is, when does this get called? On start, hide the start button, say that the start is admit that the start game has happened, and then when the on message timer times out, hide the message. Okay. So still nothing calling update score. Connecting HUD to main. Now that we're done creating HUD scene, go back to main instance. A HUD scene in main, like a different player scene. The scene tree should look like this. So make sure you didn't miss anything. So I gotta add HUD. Okay, save this guy. Go back to main. Add. How did I do it? I did the link. HUD. Okay. Scene should look like this. HUD. Now we need to connect the HUD function to our main script. This requires a few additions to the main scene. In the node tab, connect HUD start game signal to the new game function. I knew there was a start game somewhere in there. All right. A function of the main node by clicking pick button in the connect to signal window and select new game. Connect HUD start game. New game method of type new game below receiver method. In the window, verify that the green connection icon now appears next to func new game in the script. All right, start game to new game. So node, start game. Do I have to click on this guy? Start game. And the receiver should be on HUD start game. Pick new game. Let's see if I did that right. On mob timeout, on start timeout, on start timeout, on game, on player, on process, on. I think I did it backwards. HUD.update score. In new game, update the score display and show get ready. Verify that the green connection icon now appears next to the func new game in the script. New game, new game, new game, new game, new game. Here's the new game. And it is hooked up. Okay. Hooked up to the HUD. Okay. I think that's right. Find out soon enough. In new game, update the score display and show the get ready message. So how do I have access to HUD? Oh, because yeah, it's on the same, it's in the main scene. Update the score, and the score is starts at 0. Show the message. Okay, and then when we update the score, then show the game over and game over. That makes sense. We get game over when we die. New game process on player hits. Game over. Game over. Okay. Finally, add the on score timer timeout to keep the display in sync with the changing score. On score timer timeout. On start on score. Okay, so we are updating one every timer timeout and then update the HUD. Makes sense to me. Remember to remove the call to new game from ready if you haven't already. Oh, good call. You go away. Now you're ready to play. Click the play the project button. You'll be asked to select main scene. I already did that. Expected indented block. Yeah, this guy. I was wondering if it's going to call me out on that. Hey, you are indented. Pass. All right. Moment of truth. So, 0. Destroy the creeps. Start. And then 2 seconds later. Ah, it didn't work. Start. Start. Okay, so I must have wired this up wrong. So this is on new game. Start timer. Go to this guy. Timer dot start. Score timer start. Start timer timeouts. Where's the on timer timeouts? Did I do the wrong one? On start timer timeout. Yeah, you click start button. Maybe the click start button is wrong. Where's the start button? Start when it's at HUD. Yeah, where does start button do anything? Must have missed that. Pressed. Yeah, when we didn't hook up start button. Where did we miss that? Start button. Start game. Show message. Message. Update score. On start button pressed. How did I keep missing these sections? All right, connect the press signal of start button on the timeout signal of message timer and add the following code to the new functions. So start buttons pressed on the timeout. These signals they seem so backwards to me. Okay, but on start button pressed, you call start button hide, start game emit. Cool. So wherever we have a start game signal, we want this function. Let's do that. Start game, it's right there. So let's add this. Oops. So on start button pressed, start game emits. Doesn't like it. We already have that? We already have that. Ooh, so we did add that. Okay. We did add that. So then what went wrong? Well, let's do a log. What do I always say? When in doubt, log it. Okay. And then the timer we care about is actually start timer, on start timer. On start underscores. Oh, that's player. Oh, main. On start timer timeout. It's just acting like I didn't press it at all. So it's not hooked up somehow. Okay, let's see. How do you hook this up if that's not it? On start button pressed. On start button pressed. Start button. On. So here's pressed. Base button. HUD. On start button pressed. I already have. But now it's connected. See, it wasn't connected before. It's so weird. These are magical signal connector things I just don't get. All right, and then the other one is on message timer. Timeout. Message timer. This guy. Magically connect. There it goes. Okay, there's some magic in that. I guess I gotta go through those steps. There we are. 1, 2, 3. Game over. Dodge the creeps. Is it supposed to clear the enemies? I kind of like that it doesn't. Let's see what my high score could be. Whoa. Yeah, I think you're right. I think you need to connect stuff. I thought it was name like function based, but it's not. There's something in the background that's wiring these things up. I bet if we were using C#, it'd be more explicit, but there's some auto magicalness happening with GDScript and Godot. Oh my gosh, that was a lot longer than I thought it would. Well, I kind of knew it might take a while, but we did it. I feel like just these tools, just a little bit I learned about animation, the movement, collision, like I'm going to use like all of that in the game I'm trying to make. So pretty happy with this tutorial. Very cool. All right. Oh, removing old creeps was supposed to do something. Did we just not get to that part? Yeah, we didn't get to that part. Okay. I kind of like that the creeps keep floating around. I'm glad I had someone to watch, man, and chat with me. That was really cool. Appreciate that. I'm going to do more of these. Maybe not always game development. Some just AI coding, some app coding, but definitely want to get farther on this game that I'm trying to build. Moving old creeps. Okay, if you play into a game over and then start a new game right away, the creeps from the previous game may still be on the screen. It would be better if they all disappeared at the start. Oh, okay, start of new game, I agree. Not at the end. I like them floating around. We just need a way to tell all the mobs to remove themselves. We can do this with a group feature. In the mob scene, select the root node and click node tab next to the inspector. The same place where you find node signals. Next to signals, click groups. And you can type a new group name and click add. Now all mobs that will be in the mobs group will be in the mobs group. We can then add the following line to the new game function. Get tree call all group. That's cool. Queue free. The call group function calls the named function on every node in a group. In this case, we are telling every mob to delete itself. The game's mostly done at this point. In the next and last part, we'll polish it a bit by adding a background. Oh, I need to figure out how to do that. Looping music and keyboard shortcuts. Okay, that's crazy. More, but now I gotta finish it, so I'm gonna finish it. We get rid of this log in mob. So that's what that queue free thing was doing. Queue free, queues a node for deletion. Cool. On the mob groups, mobs or mob, probably plural, right? Mobs, cool. Then in new game, we do this guy. Makes sense. In new game. New game, game over, new game, sky. Get tree, call a group, mobs, and call its queue free function. Let's try it out real quick. Okay, let's die as soon as possible. Boom. Oh, it didn't delete them. Why not? It's also possible that it takes a second to delete them. We can increase the timeout to really verify this. But yeah, it looked like it didn't work. Did I not hit add? I bet I have to hit add here. Yep. Oh, that's just something simple. Die fast, die fast, die. Oh, we got a crash. Attempt to call function update score in base null instance on a null instance. HUD. So there is no HUD. Why is there? Why would there be no HUD? Oh, did I put mobs? I must have put mobs as the group name of HUD. Oh, I'm so tired. All right, cool. The group name of mob is mobs. Deleted my whole hub. Imagine if I didn't know how to troubleshoot dumb mistakes. Searching for hours for that. Like, why is it deleting? Why is my hub gone? There's a hub right there. Where's the hub? Hey, it worked. Cool. Finishing up. You have now completed all the functionality for our game. Below are some remaining steps to add a bit more juice to improve the game experience. Feel free to expand the gameplay with your own ideas. Background. The default gray background is not very appealing, so let's change its color. One way to do this is to use a color rect node. Make it the first node under main so that it will be drawn behind the other nodes. Color rect only has one property. Okay, so the order of nodes matters. Good to know. Choose a color you like and select layout, anchors preset, full rect, either in the toolbar at the top of the viewport or this vector so that it covers the scene. You could also add a background image if you have one by using texture rect. Okay, we'll use a color rect. What's it called? Property. Doesn't really say, but I'll probably just call it background. Okay, add the color right to the top. Call it background. Pick a color. We'll go with space gray. Blackish. And then full rect. Where was that? They said there was a preset for it, but where? Full screen. Layout, choose color you like, layout, anchor preset, full rect, layout, anchor preset, full rect. There it is. Cool. Okay. Sound effects, sound, and music can be the single most effective way to add appeal to the game experience. In your game's art folder, you have two sound files, House in a Forest loop.og for the background music and gameover.wave for when the player loses. Add two audio stream player nodes as children of main. Name one of them music and the other death sound. Nice. On each one, click the stream property, select load, and choose the corresponding audio. So, audio stream player, music, death sound, music, death sound, music, death sound, music, stream player 2D, I guess. And we need to choose stream, new audio stream, no, load. Game over. God becomes music. Sky. Death sound. Death sound. Okay, was there more to it? On each one, click Stream Property Select. Load. I thought it said loop. All audio is automatically imported with the loop setting disabled. If you want the music to loop seamlessly, click on the stream file arrow, select Make Unique, and then click on the stream file and check the loop box. Make Unique. Make unique. Why do I have to make it unique? Oh, so it doesn't like spawn it. Stream, autoplay, probably want autoplay. Maybe not. Where's the loop? Where's the loop? There it is. Loop on. Okay. To play the music, add music.play in the new game function. Music stop and the game over. Music.play. Game over. Game over, man. Game over. Death sound dot play. And music. Dot stop. Hey. A little quiet on that death sound. Do. Love it. Awesome. Music stop, death sound play, yep. Keyboard shortcut. Since the game is played with keyboard controls, it would be convenient if you could also start the game by pressing a key on the keyboard. We can do this with the shortcut property of the button node. In a previous lesson, we created 4 input actions to move the character. We will create a similar input action to map to the start button. Select project settings, and then click on the input map tab. In the same way you created the movement input actions, create a new input action called start game and add a key map to the enter key. Project settings. Enter. How did I do that? I just say start game, then map it like that. Oops. Enter. Now would be a good time to add controller support if you have one available. Attach or pair your controller, and then under each input action that you wish to add controller support for, click the plus button to press the corresponding button D-pad and stick direction that you want to map to the respective input action. In the HUD scene, select Start button and find the shortcut property in the inspector. Create a new shortcut resource by clicking within the box. Open the events array and add a new array element to it by clicking on the array input size 0. Create a new input event action and name it Start Game. Input event action. Shortcuts. Empty. New shortcut. Input array. Add elements. New input event or new input event key. New input. I already forgot. Input. 1. Then it should be input, new input event key. Is that what it's called? Input event key. This just says input. New input event action. Yeah, input event action. There we go. Action. Start game. On one device. Okay. Now when the start game appears, you can either click it or press enter to start the game. With that, you complete your first 2D game in Godot. Okay. Enter key. Ready? Game over. Game over. Love it. All right. Thanks everyone for watching. That was a really good stream. It was a really good chat today. Thank you guys. Shout out to Murdered with 3s instead of E's. Red Dragon 72Q. Really appreciate you guys jumping in. And to the rest of you watching on YouTube, watching the VOD, thanks for watching. Till next time. Right out. Other cool stuff. Good night. Bye.
Thank you.